Good evening, everyone. Welcome to the 12th hour of week 5. How has everyone been doing?
Pretty good. How are you?
I'm fine. That was Yuichi. Great to hear.
Hi, Jerry.
Well, we have more students coming in. So how has everyone found this class so far? Was it challenging? Was it quite informal? And have you find it to be relevant to what you have been doing at work? All right. So unless there are additional comments, then we can jump into the Q&A session of homework 5 or other questions you may have.
I guess I have a question.
Hi, Eugene. Yeah, what's your
So,
question like?
we saw that the alpha in our equation is, whether it's 0.6 or 0.3, it shifts the exponential smoothing model.
Yeah.
I was wondering if you could go over, like, I think the professor went over it too, but I just wanted if you could reiterate, like, what is a optimal alpha? And like, I know that the alpha models, a higher alpha or a lower alpha is more stable and adjusts less quickly to changes and swings. So if you could comment on that as well.
Yeah, so the alpha is a smoothing constant. Basically, it's a weight between the latest observation and the ones beforehand, right? So if we use a higher weight on the most recent observation, then as you said, the changes would be faster than using a lower weight for the latest observation. In terms of which would be the optimal alpha to choose, it depends. A very typical criteria is using a goodness of fit measure, just like R square. So if we find an alpha weight or the smoothing constant value that maximizes the fit of our model relative to the observed data, then we would typically choose the one that gives us the best fit. Did this address all of your questions? I think,
yeah. So
yeah, you raised a few.
So are we expected to? I didn't run a regression model on the exponential smoothing value, I guess you could say. So that's something that we can do, and then find the R squared is what you're saying.
Yes, you can possibly run multiple possible regression models of using different alpha value for the smoothing constant. And for example, the first one, you may choose an alpha of 0.1, and the next one, you choose an alpha of 0.2. Then you may have up to 10 if you divide, using alpha equal to 1. Does it make sense? I think, yeah, it also works, I guess. So you run all these possible models, then you choose the one that fits the data the best. However, there are other criticism of professionals doing against it. Usually a better performing way is using a technique called cross-validation. So we are not seeking the one that fit the current data best. We are seeking the one that predict future values the best. This is a new concept you might learn in the future.
Okay, thank you.
Wonderful. In terms of, so we were discussing part B in assignment 5, problem 1. It's about the effect of using different values of smoothing constant. And for the question, when you answer this question, some students in the full-time, fully employed MBA students was not sure what the answer should be like. I told them that it's basically to evaluate which one is larger and which one is smaller as a result of using different values of the alpha. So part B in problem 1 is basically a comparison for the resulting values. I mean, a comparison between the resulting values. Yeah, I think problem 1 is pretty straightforward as long as you understand the concept of smoothing models.
So could I ask a question?
Sure.
Yes, so what you're saying in question 1, part B, because the constant that we're given was 0.6. So you're saying, I mean, you're saying that in order to solve that, you would choose, like, say, 2 or 3 other values of a smoothing constant and plot those. Is that what you're saying? Or do and be able to compare?
So for this homework assignment question, it's not necessary to run any model or plot. It's basically a thinking experiment. As long as you grasp the concept of the smoothing constant and the effect, you should be able to answer this question without running any models or creating any plots. But if it helps, you can definitely create a plot and fit some models and compare if it helps you to address this question.
Moving averages should only be used for so-called, I think I have the trick.
Sorry, was it another question? I heard some student commented just now. All right, if there's additional question, welcome to jump in. Otherwise, was I able to address your question, Tilda?
Yes.
Okay, excellent.
Please, thank you.
Any more questions about problem 1? Otherwise, we
Yes,
can welcome some. Oh, problem 2 questions are also okay.
So question part C of problem number 1.
All right. This is where we need to fit a model.
How does one go about it? Because I ran a second order polynomial, but I didn't understand. I didn't know how to go past running. I mean, plotting that and getting the equation. I was able to get the equation.
Oh, I was slightly confused. Did you say that you were able or not able to get the regression equation?
I was able to get the regression equation. I'm hoping that I was.
Oh, but you're not sure?
I'm not sure.
Oh, okay.
I'm sorry, but I'm not sure. So
I see. Maybe you were wondering whether the regression equation you got was correct or not. then
Yes.
Please share with us so we can work on that.
I think I got
So-
like an R square of about 65 or 66.
I'm not sure whether I understood correctly, but R square should be always between 0 and 1. It's not possible to get
No,
the
I mean
values outside of that.
percent. I mean the
Oh,
percent. In
okay.
percent, yes.
Yeah, well, so far it doesn't sound that you correctly fit the model. So possibly you made some error. So if you don't mind, you can share with us the work you have already.
Okay.
Note that this part C, it's no different than some of the exercises we worked on in homework 4. So we already practiced similar questions in homework 4. So if any other students also lost track on how to run a second order polynomial regression model, you can refer to what you did in homework 4.
Okay.
I enabled students sharing their screen. So you can do so.
I'm trying to see if I can share that, but
Did any other students run into problems for part C or the second order polynomial regression model?
Tilda, maybe check your data. I got closer to R squared of, I think it was 95 or 0.953. I don't know if I did it right, but
Yeah, that's what I got too, Michelle.
okay.
Me too, Michelle.
Wonderful.
Michelle or is that Maria in the
It
background?
was Heather.
Heather,
Want me to-
yes. I mean, is it possible for maybe one of you after the class to do some walk through with me as to how you did that? I would appreciate that.
Yep.
Thank you. Is that Heather?
Yeah.
Okay. Thank you so much.
Yeah. You can also share your
no
work
problem.
with, by screen sharing now, if you don't mind.
Oh, sure.
Otherwise,
I am trying to.
That's all you,
figure
Michelle.
out how
Okay.
to,
Okay, Tilda, can you see my screen?
I'm trying to figure out how to share my screen.
oh,
That's what
I'm
I'm-
sharing. I'm
There's-
sharing mine.
oh, thank you, Michelle.
No problem.
I was thinking if Tilda could share hers, so I can possibly tell how to get from there. But it also works just fine if
will
from
try
your screen share.
to
There's a button at the bottom where you see all the names of the students in this class. So there's a button saying share screen. So you can do that.
okay. Share. That is what. Can you see it? That is the one. Are you able to see my screen?
Yes, I did. Oh, interesting. Somehow you eliminated the intercept. So how about we go to the top rows of this worksheet. Can you scroll up, Tilda? So I
Yeah,
can see
I'm
whether.
trying to scroll up.
Yeah, I would like to make sure that you have all the data included.
Not moving up.
Yeah, I was just thinking to if you can scroll up to the top rows, so I can understand what variables you constructed.
Now, the problem is that I'm unable to scroll up. I don't know what the problem is with my.
You can just drag the scroll bar.
That's what I'm doing.
Oh,
Yeah, that's what I'm.
it's not
That's what I'm trying to do. It's not responding.
Do you have a middle key on your mouse?
Yeah, I do have.
It doesn't work
The
either.
mouse itself is working,
So,
but it
okay.
is not.
Yeah, maybe you can close it and open this Excel file again. So by the plot, it looks okay. So somehow you did not include the intercept, it seems. So make sure you include the intercept in model.
Jerry.
Hi.
Jerry. I have a question. So when they ask for like a regression model, that's the data analysis that we do with the regression model, right? Not necessarily the plot, the line graph, or the scatter plot, correct?
Yeah.
Thanks.
Yes. When the question asks you to fit a model, then you should submit the summary output. But as you said, in terms of plotting, it's actually very important. I've run into occasions when the model may, I mean, the regression models looks okay, but when you plot the relationship, it provides additional insights into the data that a regression model may neglect and may not reflect all the information. Hi, Tilda, are you able to? No, I'm saying that for this question, it does not really request a plot, right? But in any way, when doing data analysis, it's really important to check the relationship visually by plotting before building any models.
Okay, thank you.
Hi, Tilda, are you able to reopen the file?
I'm trying to.
Okay, how about you come back later when you are able to share your screen? Then you can start from there.
All right, thank you.
All right, any other questions about problem 1?
No.
Then we can move on to problem 2 if you have any questions about it. Here we need to build some dummy variables and add some trend variables. Has any of you already worked on problem 2?
Yeah, hi, Jerry, it's Irene.
Hi, Irene, how are you doing?
Hi, good. Yeah, I do. So I'll just start off with question 2. So this is the one where we have to create dummy variables, right? So it in the and I don't know if I did this right, because in the question it describes that the shifts are Monday through Friday, and then there are 5 shifts within each day.
Yeah.
And so I'll just show my screen if that's okay.
Sure. Yeah.
So I wasn't sure if I'm supposed to split it where I have a dummy variable for Monday through Thursday, as well as the shifts, with the 0 being Fridays and what is that, 4 to 6, I think is the last shift. Or was I only supposed to do the shifts? Because in the problem, it seems like we were only supposed to do the shifts, but then it has 2 sets of variables that we could provide dummy variables on.
Good question. Yeah. So what you notice is that there are multiple seasonalities in this data. As you said, we can divide the season by, we can define a season by either the shift within a day or by the day of the week, right?
Right.
So what you did is okay to define the different seasonalities. If it's also okay for us now to only focus on one of them. So if the seasonal component, as it pointed out, only includes the shift within a day, it's also fine. But what you did here is also good. However, what you're missing here is the trend variable. As it requested in part A, we need to decompose it into a trend and seasonal components. So have you thought about any ways to insert a trend variable here, or you forgot about it?
You mean like to plot it on a graph? Is that what you mean by finding a trend?
No.
Or a period? Periods?
Yes. Was it another student mentioning periods? Yeah, it's the same thing. Trend here means periods. So it seems
so how do you do that?
Yeah, it seems you did not consider it so far. So do you have any thoughts on how we can include the trend here?
I don't I guess you could either bucket all the 8 to 10 shifts across all the days. That's a period. Is that what you mean?
What did you mean by bucket?
So like the 8 to 10 on this Monday, the 8 to 10 on this Tuesday, like basically grab all the 8 to 10s.
Then what to do about them?
I'm actually not sure. I would actually put them on a pivot table and then graph it. So I'm not sure if there's a another way that we should be doing that.
I see. How about other students? Any ideas of how we can insert a trend variable here?
Jerry, I don't know if this is right, but I just inserted a column and titled it period and did 1 through 50.
So the way Michelle has done it is that she constructed a variable to differentiate each of the shift by a sequential value from the first shift to the last shift. This is one good way to do so. However, there could be other ways to do the same task. Was there another question?
Can you share the screen? I didn't clearly understand what Michelle did.
So let me do so. Oh, interesting. I thought I opened the file already.
Jerry, you would just create 4 different binary variables, 0, 1, and 1 variable period, right? As a time component.
Yeah, you could also do that. Because Irene included a second set of seasonality, that's the day, the days of the week.
Right.
Some other students may not have considered this part, which is also fine. But what Irene did is also good.
Which is more preferred? Because when I looked at the data of the customers, it didn't have any kind of like weekend bump or Monday bump or anything like that.
Oh, I see. So in practice, the seasonality, whether to include multiple seasonality. So for example, here, we can consider the seasonality to be both ways. One is a shift within a day, and the second is days of the week. In terms of which one to include, depends on first, the purpose of the data analysis, and second, which one fits better. By the first criteria, if our purpose for this analysis is to, for example, assign staff to shifts, then of course we do need to differentiate our prediction shift by shift, right? We want to make sure that the shift that have more customers to visit the store have enough staffing, while those with fewer customers, we don't need as much staff. So for this purpose, it's important to include the shift. Another purpose, if it's to differentiate the number of customers day by day, then we don't need to go into the shift level data. So we can simply only have the days of the week seasonality. But another more objective criteria is to see whether there's any significant seasonality of either ways in the data set. So if we find that the shift variable actually helped us to fit a better model, then we include them. Additionally, if the days of the week variables provides additional information and they are also significant predictors, then we also include them. So I can show you later of different results of running the models in different ways.
Jerry?
Hi.
This is Karen. So if you did both seasonalities, how does that affect your period coefficient? Because that's two different kind of trends that you're looking at, right? So if you're doing, like, for instance, what Michelle did with just, or I mean, I can't remember with just like the period 1 through 50, but if you're doing weeks, then that's 2 weeks. So how does that work if you're doing two different sets of seasonality?
Yeah, I'll show you that later, because as you said, different ways of defining the seasonality does affect how we should construct the trend variable and how to interpret it. But now let's focus on how we construct a trend variable. Let's show the most basic way first. Okay. This one. All right. All right, here about the bank shift data for 2 weeks of 5 days in each and 5 shifts in on each day. So together we have 50 rows. The shifts are defined as Irene described first. We should have 4 indicators of the shift, although there are 5 different shifts. This is important because we always have k-1 variables to represent a categorical variable with k levels in total.
Hey, Jerry.
I don't understand.
Sorry, I don't think we recognize this. Is this for the bank example?
Yeah.
We're looking at Redfin results 2021.
Really? Wait.
Yes.
No, I mean, it looks-
Oh, sorry. I guess I shared a different screen. Yeah, sorry, that was another set of variable we were working, but somehow they're similar. I was looking at the other monitor, that's why stopped share. I need to choose a different screen. This one. Okay.
There we go.
So as you can see, as I just said, we need to use 4 different indicators for a category variable of 5 levels corresponding to the 5 shifts. So notice that how shift 5 is used as the reference level. Shift 5 is not directly used in a column name because shift 5 can be indicated by the other shifts. So notice that here on the sixth row, we have shift 5, the last shift on Monday. On each of the shift variables, we have 0. So this is important. I've noticed that some other students, when they constructed these shift variables, they did not indicate the fifth shift correctly. So this is how you can identify a reference level. A reference level for a categorical variable is the one that that has zeros on all the indicator variables. So if all of the shift 1 through shift 4 indicators have 0, it represents that it's none of them, right? So it must be shift 5. Because this shift is not shift 1, it's not shift 2 or 3 or 5 or 3 or 4, then it must be shift 5. And because each of the variable is represented by the values are all 0 here, so we know that when doing the regression equation, the coefficients we estimated for shift 1 through 4, none of them would apply to shift 5. So the variable value of shift 1 through 4 would all take 0 when we estimate a value for shift 5. Did this clearly address how we can construct the shift variable before we go into the trend value?
Yes.
Yes, it did. Thank you, Jerry.
Okay, any questions about how we should include the indicators or dummy variables for seasonality? Yeah, I can go further detail about how we can construct dummy variables for day of the week seasonality if we want to include them, but it's not necessary for this practice or the homework question. All right, let's head into the period. So the period or the trend is a variable to indicate the time elapsed in the model. So here, as you can see, this is the same way as Michelle did it. The professor included a variable to differentiate different shift and different days. So shift 1 on the first day would take a value of 1 because it's the first shift observed in the data set. And the first shift on the second day has a value of 6 because it's it's the next shift observed after the last one observed on Monday. So we do it all through the last one. So that's why the period variable has a value between 1 and 50 corresponding to the row number essentially in the data set. However, there are alternative ways to define the period variable. I can show it later, but this is one of possible ways to do so. Any questions about how we can construct a trend variable? So has any other students come up with alternative ways where you define the seasonality and the periods? And welcome to share with us. And I'll see whether first you made it correct or not. And second, how yours may be different and why is it so?
Jerry.
Hi, Karen.
I have a question. This is how I did it, but my question is, why is it that whenever we do these regression models, the adjusted R squared is always, or not always, but it seems like it's usually less than the R squared. when I thought that the adjusted R squared is supposed to take into account all the different coefficients. So it seems like it should be more accurate than the R squared. So was it lower usually?
Oh, sorry. Okay, yeah, I understood most of your question. What did you mean by mentioning more accurate? I missed that part.
Well, because so the higher the R squared, the better model, right, that you're getting that is predicting. But the adjusted R squared, that number is usually lower, like 87% versus 88% here with the R squared. And I thought the adjusted R squared takes into account all the coefficients.
Yeah.
So it seems like it should be more accurate.
Oh, I see.
R squared.
Okay. You're right by saying that it's more accurate. I'll explain that. But it seems you had a misconception about what it means by more accurate. By more accurate, it doesn't necessarily mean a better fit or a higher score. So that's why, and in R squared, that's, oh, okay. That's why here, if the adjusted R square is lower than the R square, then it doesn't mean which one of them is more accurate in terms of this. But you're right that the adjusted R square is always lower than the R square. And when you mentioned that, why is this so? Because adjusted R square takes account for all coefficients. It's actually just because the adjusted R square takes account for all coefficients, it does adjust. What it adjusts is the what's so-called as the small sample bias. This bias is a positive bias that the predict value or the estimated value is higher than the true value. So when adjusted for this positive bias, the value should be lower than what's it measured before. So that's why the R square is higher than the adjusted R square, because the R square does not address for this positive bias. So that's why lots of occasions we use the adjusted R square to represent the goodness of the model. Was I able to answer your question?
No, it's fine. I was just curious. I'm sure this is way beyond what we need to know, but I was just wondering. So because it predicts the bias more, so that's what I'm getting out of your answer.
It doesn't really predict the bias. It just adjusts for the bias.
Okay, thank you.
So you will notice that the difference between R square and adjusted R square might be more when there are many indicators in the model. So where were we before then? Was there another question I was addressing?
I have a question, Jerry. I don't know if this is necessarily applicable, but I love to see the graph of it. It helps me to visualize. Can you graph or chart the points for this model?
Yeah, it's possible, but it may take me a while to do so because let's see, I
have it if
yeah, oh, that'd be wonderful.
you want me to share.
Yeah, it'd be great, Richie, if you can share with us.
How do I do that?
Yeah, but let's see.
Oh, there we go. Yeah, I can share my screen. Can you guys see it?
Oh, I see. I guess I need to first stop sharing before you can.
Can you see it now?
Yeah, wonderful.
This one.
Yep.
Yuichi,
Great.
can you show us like how
Yes.
that is made? I'm really struggling with graphing.
Okay, so you have your equation here, right? Your intercepts and your whatever. So you just need to type that whole mess in there, right? So you have your coefficients and you have your interaction terms that are triggered, whether it's a 1 or a 0. Basically, you need to type that in Excel, and then that'll give you the forecast values. And then once you're done, then you need to right-click on any data point and just format your data or add a trend line. No, select data, yeah. And then what I did was I just added a new entry, and I added forecast, which says, oh wait. Yeah, it's basically takes this whole period, which is my X, and then my forecast values, which is my Y. And then it just plots my customers, basically the whatever, and then, yeah, and my forecast.
Thanks so much. I was under the impression that we could go directly from the shift and the period, all that, and graph it directly. But so Jerry, is that a standard thing where you still make an extra column to forecast the values and then graph it?
Well, not necessary. So what Yuichi showed us is that he plotted 2 series, right? I guess Melissa was trying to only plot one of the series.
No,
so,
I wanted to plot 2 to get the same look that the professor had when, he'll say, this is the model for this is the model for this graphically. And so it's just helpful to me to see it graphically, but I couldn't figure out how to do it.
Yeah, so what Yuichi showed us is a perfect way to do so. You do need to, insert another series of data that's more explicitly defined for how the data is constructed. If you select both, all the 3 series together, lots of times the program does not figure out successfully which to plot on the x-axis and which to plot on the y, because when we have 3 variables, there are 3 possible ways to combine a pair of variable, right? So sometimes it confuses the program. And if you want to make sure that it plots as we desire, so we have period on the x-axis and the observed and forecast values or predict values on the y-axis, this is the best way to do so. We first graph 1 pair of variable, then add a 3rd variable into the data series, as how Yuichi did it. So we need to select data, then add another series.
Thank you so much, Yuichi. I appreciate that.
Thank you, Yuichi.
And thank you, Jerry.
Can you also, Yuichi, also show us the model you fit there? I was curious. I mean, the summary output table. Do you mind showing us the coefficients you estimated?
Oh, yeah, like this. It was exactly what you got, Jerry.
Oh, I see. You have period on the last row, and
yeah.
Okay. Wonderful. Okay, now how about we take advantage of the your work here, then we can practice on the rest part of the part A in problem 2. So let's interpret some of the coefficients. So let's start with coefficient or shift
you want me to
1.
Stop sharing my screen, Jerry, or?
Let's see, is it better or not? I guess it's fine for you to continue sharing, right?
Yeah, I can. Let me do this. There, it's easier to see.
Oh, thank you.
Yeah.
So if we estimated a value of negative 1.44 for shift 1, what does it mean? Can one of you volunteer to supply a candidate answer?
It means that for every that shift 1 has 1.4 less visits than shift 5, because everything is relative to shift 5, right? So those coefficients essentially point to how they would adjust according to your reference period, which would be your zeros, in this case 5.
Wonderful. That was Hugh. Great answer. So he was right that these coefficients are relative, represents the difference between this shift relative to shift 5, which is not shown directly among the coefficients. That's why it's recognized as the reference value. Did any other students have other thoughts? Did any of you interpret the coefficients in a slightly different way and wonder whether it's correct or not?
Jerry, the B1 is the slope that corresponds to the period, correct? Indicating that customers increase an average of 0.216 per period regardless of the shift, is what I came up with. Is that correct?
You were talking about the meaning or interpretation of the coefficients.
The coefficient of the period, yes.
Yeah, it sounds correct. Could you repeat it?
That slope corresponds to the period, indicating that the number of customers increases 0.216 per period, regardless of the shift.
Yeah, wonderful. Sounds good. So notice that in a plot which you made, the green lines representing the predicted values have a slight upward trend from left to right, right? So that's why this estimated coefficient of the period is positive, because it's increasing when we take out the seasonality. So Melissa was also did an excellent job when she mentioned one of the periods when she also addresses the other coefficients. The way she did so is that when she mentioned regardless of the shifts, right? This is important in multiple linear regression. When we interpret one predictors among many others, the meaning of the predictor is when the effect when holding other variables constant. So in this case, that means if we take out or remove the effects of seasonality, which is the shift of the day effects, then this period increases shift by shift by 0.216. So we do need to mention that the effects of day of shift is removed when we address or interpret the coefficient of period. So
Jerry,
this is excellent. Karen, hi.
So I said a little differently, but I don't know if it's correct. I said that instead of regardless of the shift, I said it increased by 0.216 from shift to shift.
Yes, that's actually the meaning, because when you because that's how the trend or period variable is defined. As you noticed that it increases by 1 from one shift to the next, right? So this coefficient is the difference of the value when we increase the predictor by 1, right? So,
So
yeah,
that's
you did a
okay
good
to
job.
say it that way too. Okay.
Yeah. So you could, although it's not, directly reflected in the in a plot that we do not really see the predicted value is increasing from shift to shift. So this is why it's important to mention that this coefficient of period is the underlying trend when we remove the effect of the day shift of the day. So wonderful. It seems you did an excellent job in interpreting both the seasonality and the trend so far. So yeah, it looks great. Thank you, Yushin, for sharing. And now, using the last few minutes, I can point you to some alternative ways to define the seasonality and trend. So what we have discussed so far are all good ways, and they are correct, but there are also alternative ways to do so. And if you did it in a similar way as one of these additional ways, then it's also good. So here, as I show, as we discussed earlier, we can have 4 seasonality variables representing shift 1 to 4 with the 5th shift as the reference, and include a period increasing from 1 to 50, representing each of the different shifts within the 2 weeks, right? However, it's possible to define period in a different way. So for example, here, period 2 is a second way of defining the period. As we can see, Monday has all value of 1 here, and the Tuesday, all the 5 shifts on Tuesday have value 2 here. It increases from 1 to 10 because this period represents the day observed in the data. So day 1 in the data has a value of 1, day 2 has a value of 2, and the last day, which is Friday of the 2nd week, right? It's the 10th day, so it has a value of 10. So if we use this method of defining the period or the trend, we have a slightly different model estimated. So notice that it does it affects the coefficient of the shift slightly, but most important is that this period 2 coefficient is different than what we did before when we defined period from 1 to 50. So can some of you students have an idea of what this, how to interpret period 2 here? I hope it's not too complex. Any idea of how we can interpret period 2 if we define it?
Jerry, is that the difference between Monday, Tuesday, Wednesday, Thursday, Friday? So it's from day to day, there's an increase of 1.08.
Wonderful. Yes, Melissa was right when she described the meaning of the period 2 here.
But I tried to do that. And then once I got to the 2nd week, again, graphically, how do you differentiate? And I'm sorry, I missed your, did you go to 6, 7? Okay, that makes sense. Thank you.
Oh, sorry. Well, what did you mean by it makes sense or not?
Well, I went 1, 2, 3. First, I started and did 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But if you separate it into 10, then that makes a lot more sense.
Yes.
So is there a correct or an incorrect way to do it, or do both methods give you the right answer, essentially?
So as you may have suspected, the earlier way you did so was not correct. This can be checked by seeing whether the trend variable increased from the beginning to the end. What you did earlier to have a recurring values from 1 to 5 and also values between 1 to 5 for the second week won't make sense because it does not make it a trend anymore if we, if the values reoccur.
And I understand that piece, but as opposed to separating it into 50 some periods or separating it into 10 periods, which is the preferable method, or are both acceptable essentially as a correct answer or just in practice?
Yeah, good question. So both ways are correct. If you did in a previous method defining period from 1 to 50, representing each shift, then it's fine. Here, I supplied a second way to define period by the day observed, right? It's also okay. What's really important is that when you interpret it, understand what you did. As Melissa mentioned earlier, for the second method, we want to make sure when we interpret the period coefficient, we need to refer to the day-by-day change, right? However, in the earlier example, we define a period from 1 to 50, then the coefficient would be shift-by-shift change. So I would personally find this second method of defining the period somewhat easier to explain, right? Because we already grasp the shift by shift effect, or the shift variation by using the dummy variables. So it sounds more easy. It sounds easier to comprehend a trend by day by day increase instead of shift by shift increase, because between shifts there's already the seasonality. Then if we already add another trend, just conceptually it's slightly more difficult to understand in my understanding. But as you can see, both models, I believe they should have exact same R square. As you can see, this is 8868, right? And this one 8868. It's the exact same value, even if when we differentiate by the last digit. And of course, it also means the adjusted R square equal between these two models. The reason is that both ways of defining the period essentially supply the same information. So either way does not have any more or less information than the other. So that's why we have the same R square. However, the coefficients estimated differ because those coefficients represent effect. The earlier way is the effect is assessed by shift to shift increase, and the second one is day by day increase. So that's why they differ. So was I able to successfully introduce alternative ways of defining the trend variable?
So sorry, where was the one that Irene did? Monday, Tuesday, Wednesday?
Oh, all right. Okay. Oh my God, I have only one last minute. Okay, here we go. If you want to understand what's the use of adding additional seasonality variable, here we go. Let me see what's the difference between these two. Oh, I see. Oh, okay. So first, before introducing the second way of defining seasonality, let's look at why it's important to drop shift 5 out of the model. So here is a model. It's the same as this one I did using period 2 and 4 indicators of shifts, except that I include all the 5 shifts indicators. So notice that how the shifts are defined here. If we insert a fifth variable to represent the shift, especially shift 5. So that shift 1 would have value of 1 for the first shift of each day. Notice that it's the same for the first shift for Tuesday, right? It goes the same for shift 2, only the shift 2, only the second shifts, the rows representing the second shift would have a value of 1 on this shift 2 variable. So it's the same. The fifth shift would have only a value of 1 on the shift 5 variable. So that when we add all these 5 shifts indicators, they would equal to 1, right? So for row 1, we only have one of these 5 variables with a value of 1. All the other 4 would have value of 0. So if we add all these values, as you know, the sum is 1. This is always true if we go to the last row. The sum of these 5 shift variables is 1. Yeah. If we throw all these 5 shift variables into the model, notice that here some of you may notice the errors. One of the p-values is not a number anymore, and the coefficient would have value of 0. So the reason why we have this result is that the computer automatically figures out that not all of these 5 variables are necessary. So it automatically throws out one of them. Otherwise, it's not possible to estimate the model. And by default, the one that's not to be included is the second variable. So make sure when you estimate the models for the shifts, you include only 4 of the 5 shifts and use the remaining one as the reference. And it should not be selected as the X or the predictor series in the regression model. So as another student pointed out, it's possible to include another seasonality, that's the day of the week. So here I have additional variables. We still have the 4 shifts to differentiate the 5 shifts. And I also include a trend or period representing the week, and also another set of seasonality representing day of the week. And we follow the same rule of define a categorical variable to throw away or use one of the levels to for the reference level. So here, implicitly, I use Monday as the reference. So each of the variables of the day of week would not include Monday. So I only have Tuesday through Friday to differentiate the 5 different days considered in the model. Then when we include all these variables into the model, then we have this set of value included. So now I would welcome one of you to interpret the coefficient of Tuesday here. Does any of you would any of you like to try how to interpret the coefficient 1.2 corresponding to Tuesday?
So you'll see 1.2 more customers on a Tuesday, all else being equal?
Almost correct, except for we should also include a reference here.
Oh, compared to Monday.
Yes, correct.
I see.
Exactly. So that's what the second set of seasonality would mean. So if we compare other days of the week to Monday, this is the result. So as you can see, if we include only the trend as what we did in previous model, we have a period 2 representing day-to-day change, right? It does not capture exactly the same information as we did here. Notice that compared to Monday, Tuesday increased by this much, Wednesday increased by this much. However, Thursday customers would not be as many as we had on Wednesday, so it does not exactly increase day by day. So if we have additional seasonality, we could possibly include more complex patterns. So that's why you can see the R square is higher than what we did earlier when we do not have this day by day change. I mean, a day of week patterns included. So,
Jerry?
Hi.
This is Karen. How come the shifts coefficient change in this model compared to the one without the weekday model, like the one with just the shift model? Shouldn't it still be the same coefficient?
Really good question. So they are not. As we practiced before, when we had the example of predicting revenue using advertising, right? Do you still recall that example? So when we include additional variables, the coefficient of the existing variables would also change because they are estimated model specifically. So if the model changes by introducing additional variables, the coefficients of the already existing variables would also change. And here, if we include the day of the week effects, some of the shifts coefficient would also differ compared with a model that does not include the day of week patterns. Because the without considering the day of week patterns, these shift coefficients, as in this model, would include some of the day of week patternal changes already. But if we if we remove this part, then of course it changes slightly. But it's almost the same, except that these standard errors would be smaller. Notice that here, without the day of week patterns, the standard error that measures the uncertainty when we evaluate these coefficients. Wow, it's actually larger. Oh, interesting. I thought really it's smaller.
So would you say your
yeah.
Tuesday, Wednesday, Thursday model is better because it's your R squared is higher?
Not necessarily. The R square is higher, but let's see whether any of them. No, when we assess whether a model is better than another, R square is only one of the possible reference values we use. And practically when we choose which model to use, it depends not just on which one fits better, but also the purpose of the study. And if here we just want to understand the shift by shift pattern, then the previous model is enough. We don't really need to consider the day of week patterns. But if our purpose is to do the staffing planning, then it also matters which day to assign staff members, right? So it's also important to include day of week patterns.
So the trend variable in this one is the week, right?
Yes.
So is that saying that from the trend of the 5.6 6.2 indicates that every week the number of customers increases by that number?
Yes, you did an excellent job interpreting the coefficients. Yeah, the reason why I use week here is that all other variations is already taken account for using shift by shift and day of week. All right, welcome to, oh, actually I took 10 more minutes this time. Sorry about it, but yeah, this time I introduced alternative ways of modeling. So as you can see, there's not just the only way to run or develop a model. So if you used alternative ways, it's also fine.
Well, thank you, Jerry.
Thank you, Donald, for joining us, and have a great night.
Good night.
Thank you, Jerry.
Bye, Yuxing.
Thank you, Jerry.
Thank you for joining us, Duda.
Sorry?
Thank you for joining us.
Yes. Where do you think I went wrong in what I was doing? If I can share my screen with you again. Is that okay?
Yeah, sure.
Okay. Okay. So I'm looking at number 1 here. I followed, I think this was the averages. Did I go wrong with the averages? What I did with the averages here?
Oh, that's weekly attendance. So
I mean, the attendance exponential smoothing, what it says that there was a formula that I put in here, and then I ran it down, and I don't even remember what I did, because in the end, I had this with attendance against the week. I did the scatter plot, and then I used the graph to do the regression, which I put in these 2 lines, this and this, the trend line for the scatter plot. And then I clicked on one of the points and got this equation here. And it also calculated the R square. So if I may ask, I mean, if you could help me so that I can write down, like, just the actual steps of running a regression itself. Because I've done it, but I don't know why it doesn't stick. I've done so many, but it just seems like it's not sticking, that when I get posed with another situation, I'm not able to get to the charts. Like, say, if I were to get that table, to get the table before, I mean, where you've got the table, the coefficients and all that. Because now, if I had the table, I would be able, and I did it I did it in the previous exercises, but in this particular case, how do you get to the table with the R square without having it graphed? How would you get the regression?
Were you not able to do so previously?
I have done it, but I don't know what is gotten blocked in my brain that I don't remember how to do it.
Oh, I see. Then I would suggest you to rewatch the videos in previous week.
That's what I've been doing. I went back to the videos, the previous videos, and
yeah.
But my worry is the time for the homework as well. So
I was kind of lost here. So you were able to fit regression models previously, but not this time?
Yes, I mean, I think, I mean, I know I can do it, but the thing is that, did I calculate this correctly? Do these figures look correct for number one?
For number one, it's fine, but you're asking very different questions. For number one, it has nothing to do with fitting a regression model. Because
okay, but then, I mean, with this chopping, with this, okay, with this number one, because when I said that my R square was 65.7, I mean, around 90, I mean, I think Michelle said that it was about 95 or something, it was higher. And I don't understand how she got it to be a 95. Does it mean that I did not plot correctly? And that's where I'm concerned.
So first, for part B of problem one, you need to fit a regression model, not on the graph, but using the summary output table. So just run a regression model as we did previously. In terms of the trend line, you added a wrong trend line. That's the reason. So the second order trend line, it must include an intercept. When you inserted the trend line, you did not select this or check the button. So that's why you saw it an incorrect trend line added to the chart. That's the reason. So why not you set a regression model just like what we did previously using the data analysis tool. Yeah.
Right.
It's no different than what we did previously, but before that, you should include a squared value as the variable.
So in other words, from this data, I need to find the R square values. I mean, the squared values of, the squared, okay. Okay, so I have to create a column with the squared values.
Yeah, as instructed. We did the same practice previously in the homework questions.
Okay. And then that is what I graph. That's what I use in the regression model.
Yes. Yeah, plotting is different than developing a model, so do not confuse between these two.
So in other words, I mean, I would take this from the mean and square it, right? I mean, each value, take it from the mean and square it.
Not from the mean.
I mean,
squaring a value does not need a mean.
I think I'm really confused. So for example, now attendance week 1 is 14,560. So I would square that 14,560 squared and get a value of that.
Yeah. So we did the same practice in homework 4, problem 2. So if you lost track of what we did, you can refer back to homework 4.
Okay. All right.
All right. Thank you for
Thank
coming
you.
to the TO server, and hope that was helpful.
Thank you.
Bye, Tilda.
Okay. Bye-bye.